We're going to just keep chugging along, going to 4.4. So now we're going to start with example 2. So if we look at example 2, we have 4y double prime minus 4y prime minus 3y equals cosine 2x. Again, we know that our y is going to be the superposition of our complementary plus our particular. So we first need to find the complementary solution. So to find the complementary solution, what we're going to do is we're going to go ahead and find the solution to the homogeneous part. So we go ahead and we make all of our y primes, y prime, y, m squared, m, and m. And we're going to make it a quadratic and solve it, set it equal to 0. When we do that, we notice that, okay, we factor, get 2m minus 3 times 2m plus 1. And then m is equal to negative 1/2 and 3/2. So then our complementary solution is just going to be y sub c equals c sub 1 e to the negative 1/2 x plus c sub 2 e to the 3/2 x. All right, so we found the complementary part. Now what we're going to do is we're going to notice for our particular solution that we're cosine of 2x. So what's cosine of 2x? The particular should be, it should be a cosine 2x plus b sine 2x. Now let's go ahead and take the derivative of y sub p. The derivative of a cosine 2x is negative 2a sine 2x. The derivative of b sine 2x is 2b cosine 2x. Take the second derivative of that. Negative 2a sine 2x is going to be negative 4a cosine 2x. 2b cosine x is negative 4b sine 2x. So now that we found all of our derivatives of our particular solution, we're going to substitute that in now into our differential equation. So substituting everything in, all of this comes from our y double prime of p, y prime of p, and y of p. The rest is just algebra. We're going to go ahead and, we're going to substitute it in. Then we're going to distribute our coefficients, so 4, negative 4, and negative 3. We're going to have it all, then we're going to find our like terms. All right, so like this negative 16a cosine 2x is going to, let's see, does it have anything it's going to cancel out or combine with? Negative 16a and negative 3a cosine 2x, they're going to be like terms and be negative 19a. And then I'm going to find all my cosine of 2x, so negative b cosine 2x. And that's it on the same, so negative 8b cosine 2x. So now I'm going to group those together so that I have minus 19a minus 8b cosine 2x. The reason why I want to group those together is because, hey, there's cosine 2x. This is supposed to be the coefficient of cosine of 2x. What's the coefficient there? 1. There's nothing there, so we know that has to be 1. We're going to do the same thing with everything with sine of 2x. We're going to combine all those together. So negative 16b sine of 2x, 8a sine of 2x, and negative 3b sine 2x. So we're going to combine our b's, get negative 19b, combine our a's, which there's only one of them, so 8a, and then we're going to set that equal to the coefficient of sine of 2x. Notice there's no sine of 2x over there, so that coefficient would have been 0. So we're going to go ahead and, dang it, I'm going to have to just hit undo. So we're going to go ahead and set that equal to 0. So notice right here, we're setting negative 19.8b equal to 1, and 8a minus 19b equal to 0. And then we're going to solve using elimination method. I mean, you could solve using substitution method, or you could graph this if you want on your graphing calculator and see what your solutions are going to be. All right, so we go ahead, we set them equal to 0. We notice, let's multiply the bottom by 19 over 8 so that we can cancel out to the a's. So when we do that, notice that second equation is going to be 19a minus 361 over 8b. So that really stinks, all right? So when we add these, the a's are going to cancel each other out. The b's are going to give us negative 425 over 8b. That's equal to 1. So b is equal to negative 8 over 425. Then over here on the left, we're going to solve. We're going to plug in for b, negative 8 over 425. All right, now one thing I notice here is I'm not going to multiply the negative 19 and negative 8 because I have an 8 with a. I know the 8's will cancel each other out. So when I put it to the other side, divide by 8, the negatives are going to cancel out. And I'm going to be left with negative 19 over 425. So there's the A. So now I found my A and B. All I have to do now is plug this into my y equals. So here's my y sub c. And then I'm going to plug in the A and the B for cosine 2x and sine 2x for my particular solution. And that should not say y sub p. That should say just, whoa, too much. Y equals that. I almost stopped the recording because I forgot there's an example clue here. All right, so y double prime minus 16y equals 2e to the 4x. Same thing. We need a complementary solution, particular solution. So we're going to take care of the particular first. Take m squared minus 16, set that equal to 0. We do that, we get m is positive 4, negative 4. So that means we get y sub c, c sub 1, e to the 4x, plus c sub 2, e to the negative 4x. All right. Now, let's look over here. We have 2e to the 4x. So we know that, our solution, our y sub p should be, it should be a e to the 4x, all right? But there's a problem, and that problem is located right here, all right? That right there is a e to the 4x, because a is a coefficient, c sub 1 is a coefficient, it's a constant. So we already have the solution. So just like we did in the last section, if I notice that, I have a solution that repeats, then what's going to take care of that is, then we'll just put in an x into that spot, and now we have another solution, and we're going to put that x there. So just like the last one. So instead of having to do, what we did and do the reduction of order to find that, now we already know if we have our solution that repeats, we can just put an x there, all right? And again, we continue to put that x there until we have a solution. So it could be ax squared if there was already an x there. Say if 4 repeated twice for our, for that solution. So we're going to go ahead and erase this, and we have y sub p is equal to ax e to the 4x. Again, there's that x there, so now it's something new. What stinks, because it would have been nice to take the derivative of ae to the 4x. It stinks to take the derivative of ax e to the 4x because that's going to be a product rule. So we take the derivative, we have the product rule here. We take the derivative again, we have another product rule that we have to take care of. Combining my like terms, I get, y double prime ae to the 4x plus 16ax e to the 4x. All right, now, plugging those into our differential equation. Again, this comes from the y double prime. Right there. That's y double prime. And then minus 16y, so that's y. Algebra. Going to distribute, combine like terms. When we do that on the left-hand side, we notice that 16ax e to the 4x minus 16ax is going to cancel out. We're left with 8a e to the 4x, and that's equal to 2e to the 4x. We're going to go ahead and solve for a. So again, the e to the 4x are going to go away. And we're going to set 8a equal to 2. Solve for a, and we get a is equal to 1/4. And so now we have our particular to be 1/4 x e to the 4x. And we're just going to go ahead and put that into our solution. And then there's our solution. I don't know why I did that. I was just going to box it this way. All right, so if I'm going to go ahead and do this one. If y sub p contains terms that duplicate terms in y sub c, then y sub p must be multiplied by x to the n, where n is the smallest positive integer that eliminates that duplication. Okay? So, it leaves this here is because really I think I was supposed to do all of this part down there, but I didn't. So I'm just going to give you like another example. So say if, you had, your differential equation. So remember, it's a linear differential equation. So Lx is equal to, say, e to the 2x. All right. And when you solve for L, for the homogeneous part, you got your y sub c to be, you say your m was equal to 2 and 2 again, so it was multiplicity 2. Then your c sub 1 would be, your y sub c would be c sub 1 e to the 2x, plus, since it's a multiplicity 2, I have to include that e to the 2x. Now, because I have this, and then I know that my y sub p would have to be a e to the 2x, but a e to the 2x is already there, then what I would do is, okay, let's put an x there. There's a problem. That's already there as well. So therefore, I'm going to go ahead and put a square in, and is that there? No, so I'm good. All right, so again, I can continue to do that until I don't have any solutions that repeat.